Hello students, welcome to the next chapter of class 11, that is straight lines. Now in the first video, we will learn different formats of the straight lines, right? Before that, I would like to introduce you a new term which is required for every equation of a straight line. Now see, I have made a line here. This is x-axis, this is y-axis, right? Now this is our line L. So every line has some inclination towards the positive direction of x-axis, right? It will be making some angle with the positive direction of x-axis. So the basic thing which we require to make the equation of a line, which is always required, is called the slope of a line. Slope of a line. Slope is also called inclination, or technically we also call it gradient of the line. They mean the same thing. Slope of a line or gradient of line. It is represented as m. So if we have to make equation by any of the formats that we are going to learn now, m is required in every case. Slope is required. Now how can we find the slope of a line? So there are two different methods. If this angle, see, you always have to consider the angle with respect to the positive direction of x-axis, not from here. This is negative direction of x. So always consider the angle from the positive direction of x-axis. Let this angle be theta. So m can be written as tangent of this theta. Slope of a line is tangent of theta or tan theta. This is one way to find the slope of the line. The next thing is, if we have 2 points on the line which are given to us. Let's say A be a point whose coordinates are x1, y1, and B another point x2, y2, right? These are two different points. If 2 points on the line are given, in that case, slope can be found by using the formula y2 minus y1 upon x2 minus x1, right? So these are two different formulae to find the slope of a line. Once the slope is known, there are different conditions according to which we can find the equation of a line, right? So the very first case is lines parallel to the axis. Axis is the plural of axis. X-axis, we have two axes. Y-axis, right? This is a singular term, this is a singular term, the plural is AXES. So the line can either be parallel to x-axis or it can be parallel to y-axis. Let's consider the first case. Let's say these are the axes. This is x-axis and this is y-axis. Let us consider we have a line which is parallel to x-axis at some point, right? Let's say this is 1 and this is 2. Now you have to remember, see, the formats have to be remembered. Like if a line is parallel to x-axis, what kind of equation will it have, right? You can see that the whole line is parallel to x-axis and it is cutting y-axis at a particular point. So when this is the format, the equations are of type y is equal to a. That means y is equal to the coordinate or the point where the line is meeting y-axis. Like this line is meeting y-axis at 2. That means on the whole line, you can see that whatever the point on x-axis is, but the y remains 2 for the whole line. So we can simply say that equation of line is y is equal to 2. So when the line is parallel either to x-axis or y-axis, the equations are simply equal to the coordinate on the other axis. Like here, the line is parallel to x-axis, but the equation is of the form y is equal to a, right? Let's say we have a line which is parallel to y-axis. Right? See, this is our y-axis. This is our x-axis. Let's say I told you when the line is parallel to x-axis, the equation will be of the form y is equal to a. When the line is parallel to y-axis, you see this line will be meeting x-axis at a particular point. So the equation will be of form, let's say x is equal to b. So in this case, what is the point where this line is meeting x-axis? It is -3. So the equation of the line is x is equal to -3, or you can write here as x plus 3 is equal to 0. This is the equation of line. Here we can write this as y minus 2 is equal to 0. So when lines are parallel to x-axis or y-axis, the equations are of this kind. The next format is one-point slope form. One-point slope form. As the name says, let me do line first. Let this be our line. This is y-axis. This is x-axis. One point. That means in this format, one point on the line will be given to us. Let's say it is A, and the coordinates are x1, y1. The next thing is slope. Slope, that means slope in the form either m directly will be given to us, or either of the two cases that you remember. Let's say theta is given to us, then we can find m from theta, right? So such a format in which one point is given and the slope is given, the equation of the line is y is equal to mx m y minus y1 is equal to m times x minus x1, right? That means slope is given to us. Let me do one example here. Let's say the inclination, the line makes an angle of 60 degree with the positive direction of x-axis, and the line passes through a point 2, 3, right? Now point is given and slope is directly not given, but you can easily find slope from here. So what is m now? M is tan theta. That means tan 60 degree, which is √3. So the slope of this line is √3. In this case, we can find the equation as y minus y1. What is the y coordinate of this point? It is 3. M we have found √3. X minus x1, which is 2. So we can form and simplify this format, √3x minus 2 √3. See, the line generally linear equation in two variables. We will be getting equations in two variables. The basic format is of this type. So whatever format you are using to find the equation, you can write the form. final answer in this form. This is root 3x minus y minus 2 root 3 plus 3 is equal to 0. This is the equation of line which we have found by 1-point slope form, right? Next is 2-point slope form. 2-point slope form. In this case, this is an extension of the previous case. Like if we have 2 points given on the line, let's say A is given as 1, 3. B is given as 4, 7, right? This is y-axis, this is x-axis. Now, 2-point slope form is simply the modification of the previous form. How can we do this? The equation says y minus y1. Now, we had, this is the case, first case, m times x minus x1. We know that in the previous case, it was theta which was given to us. So we could find the slope by using theta, tan theta. Here, if 2 points are given, I had told you earlier, it is a method to find slope from the 2 points. So what happens here? Instead of writing m, we can write y2 minus y1 upon x2 minus x1, which is nothing but the slope itself. Right? The rest of the things are same. We have modified m into this thing because we can find m from these 2 points itself. Now I am making an equation by using this example. Y minus y1. You can take any of these points as x1, y1. Let's do it by this. Y minus 3. Here we have y2 minus y1. This is y2, y1. 7 minus 3, 4 minus 1, right? And here we have x minus x1, which is 1. So the equation now becomes y minus 3 is 7 minus 3 is 4 divided by 3. Now you can simplify this. 3y minus 9 is equal to 4x minus 4. Or we can write 4x minus 3y. 4x minus 3 minus 4 plus 9 is plus 5 is equal to 0. Right? This is 2-point slope form. It is simply the modification of 1-point slope form. Now the next is slope intercept form. Slope intercept form. We very well now know what is the slope. This is the line L. This is y-axis. This is x-axis. Now, if slope is there, somehow we can find the slope. And there is no point given to us. Instead, we know the point where the line cuts the y-axis. Slope intercept form. This format is given as y is equal to mx plus c. Right? M, we know that this represents the slope of the line. Now, it might be given to us directly or the angle may be given to us so that we can find tan theta and write the slope. What does this C represent? This M represents the slope. This C represents the y-intercept of the line. Y-intercept. What is y-intercept here? Y-intercept is the line segment. Line segment which this line will make at y-axis, right? The portion of the y-axis, a part of the y-axis, length which is being cut on y-axis. Now, measuring it from the origin, it is meeting y-axis at 2. That means the intercept here is 2. So C becomes positive 2. Had it been in the negative direction, we would have taken negative 2, negative 3. The value of C comes from that particular point where the line is meeting y-axis. So in this case, let's say um, M is angle theta is given to us as 60 degree. So M becomes tan 60, which is root 3. So the equation of line becomes y is equal to M is root 3 x plus C is 2. Y is equal to mx plus C. Right? Now we are going to do the last type of format of equation, which is the intercept form. Which is called intercept form, right? Let this be y-axis, this be x-axis, and this is the line L. Now see, 1, 2, 3, let's say this is 4. I'm just trying to make things unequal so that we can 1, 2, 3, 4, let's say 5. Now, what is intercept form? Intercept form is the form in which a line is cutting x-axis as well as y-axis at two distinct points. The form of the equation is x upon a plus y upon b is equal to 1. This is the format. Now, what does this a represent? A represents the length of the intercept the line is making on x-axis. You can see here the line is cutting x-axis at 0.5. So the x-intercept or the length of the part of line which is it is making on x-axis is 5 units. And on y-axis, you can see that here it is cutting y-axis at 4. The length of y-intercept is 4, length of x-intercept is 5. So the equation of line becomes x by 5 plus y by 4 is equal to 1. Right? So these are the different formats of a straight line. As we will do questions further, then you can easily know how to find the equation, whatever is given to us, how to use it to find the equation of the line. Right? So I hope you liked watching this video. And if you have any doubt or you are planning to join classes, do let me know through up and through. Thank you.